Hi friends, welcome back to the channel. Today we will solve a problem from the topic hinge beams. Hinge beams, it's not very difficult, but there is only one thing that we need to remember when we talk about hinge beams. So as you can see over here, it's a normal beam. We have the lateral loads acting on it. We have a roller support here. We have a fixed support here. These are all things familiar to us. But here comes a hinge. So the key concept is hinge joints, or whenever you have a hinge beam like this, there won't be any moment transfer. There won't be any moment transfer from this location to this location. And you can treat them as two individual beams, but there won't be any moment transfer from here to here. But the forces in this direction, if I call that as the axial direction and if I call that as the lateral direction, then force transfer will be there in both directions, both in axial as well as in lateral directions, but there won't be any moment transfer. Make sense? So now with this concept in mind, we will go ahead and try solving that problem. So now, as I told just a moment earlier, I'm trying to separate this into two beams. I can treat this as a single beam and I can treat this as a different beam, but the consideration or the constraint is that there won't be any moment transfer from this location to this location, but there will be force transfer. So I am removing this hinge and I am replacing that hinge with certain forces, bx and by. Here I am using here I am putting those signs in the opposite sense, because when you have the hinge here, everything cancels out. So Newton's third law, if I have a force in this, at this, for this beam, if I have force pointing in this direction, then for this portion of the beam there should be a force pointing in this direction. Make sense? One another thing, if you ask me why I have taken this by in this direction and all, it's a convention. I don't have to bother too much about that, because if it's pointing in the other direction, then we will get a minus sign. So don't bother about those sign conventions and all those things for the time being. In the question, they are asking us what is the reaction at this point. It's fairly easy. A much harder question would have been to compute the bending moment at this location, but they didn't ask that. They asked for the reaction at this point, which is fairly easy. So we need to bother only about this portion of the beam. So once we draw the free body diagram for that portion of the beam, it will look something like this. I'm replacing my roller support. I'm replacing my roller support with a reaction force RC, and then there is a distributed load of magnitude 10 kilonewton per meter acting over a span of 4 meter. So I have how many unknowns? I have three unknowns: bx, by, rc. Bx is 0. It comes straight out of the equilibrium of forces in the x direction, because I have no other force acting in along the x direction, which means that my bx is 0. Now the other equation I can make use of is summation of forces, or before that I can take the moments about this point. I'm taking moments about this point to evaluate RC. So if I okay, before that let's take summation of forces, because that's the order in which I have gone ahead. So if I take the summation of moments in the y direction, assuming that this is my positive y direction, upward is a positive y direction, then RC minus by minus 40 kilonewton. This 40 kilonewton comes from the fact that you have a distributed load of magnitude 10 kilonewton per meter acting over a span of 4 meter. That's why that 40 kilonewton comes into picture. Now we have another expression here over here, but there are two unknowns. I have only one equation. I need another equation. That equation comes from summation of moments about this point. I'm taking summation of moments about this point. I will zoom in for clarity. I'm summing up moments. So there will be one moment because of RC, and then there will be one moment because of your distributed loading, but there is no bending moment acting at that section because that section corresponds to your hinge location. Once I take the bending moment, this is in the clockwise direction, that's why a negative sign, and then this is acting in the counterclockwise direction, that's why there is a so this equation gives us the value of RC as 20 kilonewton. We know now we have this value for RC. Now from the previous equation, I can show you the previous equation. This is the previous equation I'm talking about. So plugging RC is equal to 20 kilonewton will give us value of By from this expression, which will come to minus 20. So now we have these two forces. By is minus 20, then RC is plus 20 kilonewton. So let me just draw that free body diagram over here. By this time itself we know the answer. This is 20 kilonewton, this is RC in the positive direction. By I assumed it in this direction, but there is a negative sign, that means 20 kilonewton is acting upwards. Then we have a distributed load of intensity or of magnitude 10 kilonewton per meter acting over this span of 4 meter, let's say like this. So if you take summation of forces in the y direction, you get 0. If you take moments also, you will get 0. So this is the free body diagram in this for this portion of the beam. Now when we move to the second portion of the beam, or the other portion of the beam will look like something like this. We have a fixed end, then we have a point load acting here. Now there is a 20 kilonewton force acting in the upward direction. Now this side we will have a 20 kilonewton acting in the downward direction. So this will be the beam on the left part, this is the left part and this is the right part. So to sum up whatever we have learned in this video, treating a hinge beam is relatively simple. Or when you have a hinge in a beam, it doesn't transfer any bending moment, but it transfers the axial and the lateral forces from one point to the other. So accordingly, draw the free body diagram and then divide the original beam into two pieces, where the division should be there at the location where this hinge is there. Then appropriately we can solve for all the unknowns in the problem. Makes sense? So thanks for watching. Hinge beams are not difficult to deal with, they are simple. The only concept is there is no moment transfer, but it transfers the axial and the lateral forces. Thanks for watching.